We are absolutely thrilled to have you join us today as we launch into this exciting new series. To help us make this event a reality, I would like to warmly introduce our official resource partner, Radio Society of Sri Lanka, and our venue partner, Sri Lanka Technology Campus. I am Dinush Pereira, representing the comparing committee of the media unit of SLTC and the organizing committee of SATVision. I will be your moderator for today's session. Now, I would like to invite our project chairperson, Mr. Vihanga Gimpan, to deliver the welcome address. Vihanga, over to you.
Good evening, everyone, and welcome to the first session of SATVision organized by SET Sri Lanka in collaboration with SET SLTC and the Radio Society of Sri Lanka. Actually, it's a pleasure to see many new faces joining this journey. A special mention to the president of Radio Society of Sri Lanka, Ms. Prarthana Lienage, for her guidance and support toward this session. We also glad to have today's speaker, Mr. Chamindu Munasinghe, with us to share his knowledge and experience. Actually, SATVision is initiated to inspire students and space enthusiasts to explore satellites, communication systems, and modern space technologies in an engaging way. Once again, welcome everyone. I hope you all enjoy and learn something new from today's session. Thank you.
Thank you, Vihanga. Now, it is my absolute honor to introduce our esteemed guest speaker for today's session. Joining us is Mr. Chamindu Munasinghe. Mr. Chamindu Munasinghe is a member of the Radio Society of Sri Lanka and is a software architect by profession, with 25 years of experience and currently working as the Chief Technology Officer for Synthesis Focus Private Limited. He will be conducting the first session on ham radio and space communication. Mr. Chamindu, the stage is yours.
Hello, can you guys hear me clearly?
Yes, Mr. Chamindu.
Okay, thank you very much. So I think I have permission to share my screen.
Yes.
Right. Okay, can you see my presentation?
Yes, Mr. Chamindu.
All right, thank you very much. And yeah, first of all, I would like to thank you guys on behalf of the Radio Society. We also have our president, Ms. Prarthana Lienage, with us, and also thank her for coordinating this event, and thank you guys for inviting us. On behalf of the Radio Society. So first of all, yeah, let me tell a bit about myself and how I become interested in ham radio. So I'm a software architect by profession. I basically design and write code, and also like from my younger days, I was interested in electronics, and then I heard about ham radio, but I did not pursue that until 3-4 years back, when I decided to become a ham operator, so that I can participate in the community, and there's a lot of things that you can gain from it, and we'll discuss about that. So first of all, have you guys heard about this term ham radio, and do you guys know what ham radio is? Anybody heard of what ham radio? I don't know whether you guys can speak. The audience, can they speak?
Yes, Mr. Chamindu, they are allowed to speak.
Okay, they are allowed to speak, right? So basically, yeah, if there's anybody here heard about ham radio, seen ham radio operators at work? No? Okay. So, yeah, let's get started. Hopefully, Then by the end of this presentation, you would have a good idea about what ham radio is, and also, um, get an idea about how useful that is and what you can do with ham radio. Okay. So for that agenda today, this is the rough talking points. What is amateur radio and a bit about its history. And we have this unique subculture in this ham community, and we do certain activities. I will talk a bit about that, and I will discuss on how to become a ham in Sri Lanka. The process varies from country to country, right? And then, of course, I think we have to do a bit of a promotional plug here, since on behalf of the Radio Society. Yeah. So I'll talk a bit about Radio Society and what kind of things we do, and hopefully how you can become a member, and hopefully, one bit of an ulterior motive I have is, from this session to get some members for the Radio Society. And then we'll talk a bit about general radio communication, about the RF spectrum, the propagation and all that, the bands that we use, and what communication modes that we use. And hopefully talk a bit about the gear that we use. And then do a bit of a discussion around how to operate as a ham radio operator. There are certain procedures and guidelines. And of course, there's a legal aspect of it as well. And then as a ham operator, what kind of activities you can do in terms of satellites and, space exploration. So yeah, and then how to become a member of the Radio Society. So yeah, I'm not sure whether there's content enough for 2 hours, but let's see as we go. So what is amateur radio or ham radio? So it's a licensed radio service for personal, non-commercial communication, experimentation, and public service. Right. So the term ham is again the origin. Even ham radio operators, they don't know how this word originated. So when you say amateur, in this context, we in contrast to professional, it doesn't mean that amateur radio operators are kind of like low of low knowledge or anything like that. So this is done as a hobby. So that's why not as a profession. So that's why it's called amateur radio. And of course, it's a licensed service. So basically, usually to receive radio signals, you typically don't need a license, right? Sometimes back we had this licensing for even to listen to radio, TV, you have got a license. But in most of the countries, especially the developed countries, you don't need a license to listen to any public radio communication. But this radio spectrum is a shared resource. So basically, there are a lot of services that use radio. For example, TV, mobile phones, and then radio broadcasts. And of course, militaries use it for communication. Ships use it for navigation, like maritime mobile radio. We use to communicate with ships, right? And then we use radio signals for navigation, the GPS, the Galileo, and the GLONASS. Those things also use radio signals. And then, you get this ISM band, where all these devices like remote control toys and drones and, like remote control gates, all of these things, we share this radio spectrum with a lot of other people and services. So basically, because of that, it is regulated. The primary governing body in the world is the International Telecommunication Union, or the ITU. ITU allocates frequencies for different services. And then in terms of ham radio in Sri Lanka, the governing body is the Telecommunications Regulatory Commission of Sri Lanka. So we can use ham radio for non-commercial communication. So basically, there's a lot of commercial services like broadcasting, television, and radio that use the radio spectrum to make money. To avoid competition with those services, amateur radio operators are restricted from doing commercial activities on radio. For example, I can't broadcast songs, so run my own personal radio station even on the licensed frequency. So this is mainly for person-to-person, point-to-point communication, right? On the allocated bands. And experimentation. We are allowed to build our own radios, antennas, and then do experimentation. And also as a public service. We'll talk about the public service part as well down the line. And we have more than 3 million licensed operators worldwide. I know in Sri Lanka, this is not a very popular hobby, but other parts of the world, especially in America and China, we get thousands of licensed ham operators. So basically, we use frequencies from 1.8 megahertz to going all the way up to 275 gigahertz. I mean, we don't have the entire spectrum but within this spectrum, we have certain bands allocated for use by amateur radio operators. These bands slightly change from different regions. We have these IRU regions. So these regions, based on the region, frequencies slightly differ. But there are frequency bands that we can use throughout the world to communicate with even with other countries, right? So, how do you identify yourself on the air? There is a call sign that is allocated to you. So these call sign allocations happen. First, the country has a country prefix. So in Sri Lanka, the country prefix is 4S or 4 Sierra. So for example, my call sign is 4 Sierra 6 Charlie Mike Uniform or 4S6 CMU. We often use this phonetic alphabet when communicating over radio, especially in communication with high frequencies on SSB. We'll come to those later, and probably I plan to do a bit of a demo. So to do a QSO with somebody on air and show it to you. And also we have this HF net starting at 7:30, the Sri Lanka Radio Society's weekend HF net. We'll try to check into that net and talk to its net controller. So this 4S part is given by the ITU, and then the other suffix is given to me by the Telecommunication Regulatory Commission, or the TRC. So in Sri Lanka, we have this 4 Sierra, 4 Papa, and a couple of other things. Those call signs, I think, if I'm not mistaken, 4 Papa is reserved for aviation, like aircrafts. And then, 4 Romeo is used for aviation, 4 Papa is used for maritime radio. And for us, we get 4S prefix. And then, in this prefix, This number 6 stands for my license class. We have 3 license classes. Based on those license classes, your privileges slightly vary. 5 is the noise class, 6 is the general class, and 7 is the advanced class. So yeah, so let's move on. So a brief history of radio. So I think you guys, if I'm not mistaken, all of you guys are learning to become telecommunication or electronics engineers. So I think you guys probably already know a lot of theoretical knowledge about radio communication, from the famous 4 equations of Maxwell, and then Hertz demonstrating radio frequencies using spark gap transmitters and receivers. And then I think the major breakthrough came in 1895 when Marconi demonstrated wireless telegraphy over a couple of kilometers. Right? And then it took on. Like this radio actually was done by amateurs in a sense, because, it's individual people, not universities or not big institutes that developed radio communication. And then in 1914, ARRL, Amateur Radio Relay League, was formed. So those days, the radio communication distance was kind of like limited to, like couple of tens of kilometers. And then this Radio Relay League was established so that people have stations. Let's say if I want to talk to New York from some other in the other end of the US, I would need to relay this message. So ARRL was founded to do that, but then it became actually a very powerful force. Although this American organization, they play a key part in making sure that our frequencies remain, because these commercial entities are always lobbying to get more bandwidth, and ham radio is kind of like at a bit of a risk. Even last month, the FCC, the Federal Communications Commission in US, kind of like for emergency use gave one of our bands to a company. So like that, it's a battle always, because amateur radio is license are given at a very low cost. For example, now I think I don't remember exactly, but it's like about 1,000 rupees per year to be for the license fees for TRC. But these TV stations and these broadcasters, they pay millions of rupees for a license. But like they only get a couple of frequencies, we get a lot of frequencies. We'll talk about that. So because of that, there's a lot of kind of tension. So these people represents the radio amateurs. And then in 1920s, they discovered shortwave and HF, like 30 to about frequencies from 1.8 to 30 megahertz. That those frequencies, they go a lot farther. So then you can communicate across countries. And then in 1961, Oscar 1 was launched. Actually, it was a beacon satellite that just broadcasted some Morse code. And then, after that, a lot happened. And then now we have software-defined radio and these digital modes and all that, internet link repeaters. It transformed the way how we do amateur radio. So what are some activities that amateur radio operators do? I mean, so okay, you have a radio and you put up an antenna, and then what can you do with this? One is DXing. DX means long distance communication. So you can talk to people all over the world. So I've been operating on HFO only for like a year or so, but I've made contacts with just a piece of small dipole wire dipole, half wave dipole, to talking with people on Italy, in England, in Australia. I've talked to people from my home. It's a very good way to meet interesting people. Like, these people also, they are also experts in different fields. Especially a lot of these guys are from electronics. They are electronics engineers or people familiar with radio, like air traffic controllers or radio officers who used to work on ships. So you get to know a lot of interesting people. And there are contests as well. We hold different types of contests. Like, it's basically about the maximum number of contacts within a given time period. There are worldwide contests as well as regional local contests. And then sometimes we also participate in other contests. Like sometimes in India, they have these different contests. Because we are close by, we can participate on those. So like that, there are contests. And then also there are like people we like to, collect contacts. For example, there are very rare DX contacts, like certain islands. There's a lot of people, but sometimes we do DX expeditions. People get together, get permission, and go to this remote island and operate. And then there's a huge competition to talk to people from that, when they're operating from those remote islands. And then we do things like fox hunts. So Radio Society also organizes, couple of fox hunts a year. So what we do is about building your own antenna and finding a hidden transmitter. So the transmitter is the fox, and then you team up, you make multiple teams, and we try to find the hidden transmitter, and the first person or the team to find it wins. And also, it's not about fun and games as well. We do a great service in terms of emergency communications. When all else fails, most of these other communication methods like cell phones, internet, depend on a third party, a carrier. Like to talk on your phone, you need Dialog Go, Mobitel, or those guys, right? Internet, you need your ISP. When they are down, you can't communicate. But with us, we maintain the infrastructure. We don't need any other infrastructure. From point to point, we can communicate. Also, we have certain repeaters as well. We'll talk about that later. Yeah. And then we can do satellite and ISS contacts. Actually, there's amateur radio in space stations, so AR-ISS. ISS has a amateur radio repeater, as well as they do a SSTV downlink sometimes, and they have a APRS digipeater that you can use to transmit APRS packets. Those modes we'll talk in the coming slides. And then there are digital modes for people who are mic shy. Like ham radio is about a lot about talking on the radio, so you have to. Some people don't like to speak to the mic. For those people, and also like with digital modes, you need a very low bandwidth, and like even like 20 dB down from the noise flow, we can communicate a very weak signal using that. We can communicate, long distance. And we do like field days and portable ops as well. Now, that is basically when we get together and go out. There are certain events like POTA and SOTA summits on the air, and parks on the air, and islands on the air. We have different things. Like, for example, Sri Lanka is an island, so we have the designation A003 island. So basically, people collect these islands, log these islands as, I communicated with this island. And then some people in America and other countries, we have this POTA or parks on the air. People go to parks, and also these parks have a number. So basically, like you make contacts with all the parks. So that's kind of like things that people do, right? Yeah, and also in ham, we have a different kind of like subculture and the lingo. Before I go to that slide, the time is 7:33. I think our HF net must be on air. I'll see if I can contact our net controller. Okay, let me do a demo. 4 Sierra 6 Charlie Mike uniform. Four S7 Romeo Sierra, 4S6 Charlie Mike uniform returning. Very good evening, Victor, and I'm on the presentation with the university group of the university students, and I have Prarthana also on this call. I think they can hear you loud and clear as well. You are 5/9 with me today. 5/9, actually 5/9 plus 10 dB with me. Strong signal, Victor. Okay, Victor, so I'll hand it over to you, back to you, and then I'll give a brief kind of like a overview, introduce you, and then maybe you can speak a couple of words to the people here. Back to you, 4S7 Romeo Sierra, 4S6 Charlie Mike uniform. Okay, so can you guys hear the radio? Can you guys confirm that you can hear that? Anybody?
We initially heard it, but the latter part we couldn't hear.
Oh, okay. So basically now that is, now I am using my HF transceiver connected to my 40-meter antenna. So the frequency we are using is 7.058 megahertz, and now we are conducting a net. What a net is basically a way for us to keep active and keep our radio gear in control, in working condition to do testing. So what happens is basically we check into the net. So there, what we do is basically we just give a signal report, and then we exchange the call signs, and basically anybody can check into the net. It is an activity that we use to keep our rigs in working order. In a net we don't do long conversations, but here I think today our net controller, one station is coordinating our net controller today is our honorary secretary, Mr. Victor. He's an Elmer. Elmer is kind of like a very senior ham, so everybody who gets a lot of respect and has a lot of knowledge about ham radio, and he's a expert on propagation. So let's see. I mean, I'll try to get him again on air. Okay. 4S6 CMU check back. Yeah, Victor. So I gave them an introduction to you as well. So basically, can you just tell us a bit about your how you became a ham operator, and then maybe like words of wisdom for the participants from an Elmer. Back to you, 4S7 RS, 4S6 Charlie Mike uniform.
Radio Sierra, the operator here and try to keep always like to say the beat is my radio and if the power goes, I just have to my battery and also in this one, coming to my first-hand information experience, having gone to color Kotmale. So why I became a radio amateur? Because I'm thrilled to use this means of experimentation. I have communicated with radio amateurs all over the world, more than 200 countries there, USA, Australia, New Zealand, South Africa, most of the countries in almost every country in Europe, all from my little radio station at home. So Chamindu, I put it back to you. 486 Charlie Mike uniform, 487 Romeo Sierra.
4S7 RS, this is 4S6 Charlie Mike uniform returning. Okay, Victor, thank you very much for that introduction. And I think there was a slight audio issue. I think the Zoom was doing this noise cancellation, and with HF, a lot of there's a lot of noise, and I think the audio was a bit low. Now I think latter part of the transmission was good. I think they can hear perfectly because I switched off the noise isolation. But anyways, Victor, thank you very much for that overview and gracing us with your presence today. Okay, then I'll go QRT for now. Later I'll try to do a demonstration with VHF as well, so that they see the difference with SSB versus FM. Okay, Victor, thank you very much for helping us today. 4 Sierra 7 Romeo Sierra, 4 Sierra 6 Charlie Mike uniform 73, and bye bye, clear.
Okay, 486 Romeo Mike Sierra, Charlie Mike Radio Sierra. Thank you, and once again, all the very best to the participants there, and greetings on behalf of the Radio Society. So good luck, Chamindu. I hope you have good weather, no lightning and thunder, and conditions will be good. 43, bye-bye. 486 Charlie Mike uniform, 487 Romeo Sierra, bye-bye.
73, bye-bye.
Okay, continuing with the next.
Okay, guys, so yeah, so that is basically how you do a QSO. I mean, I think you probably heard some of the lingo and what we talked about, right? So yeah, so in ham radio we use these different kind of words and abbreviations. So why that is because earlier we used Morse code for communication. You know, like in Morse code, typing out long sentences are kind of difficult, and also like even with voice communication on single sign band, the bandwidth we get for voice is very limited. Because of that, like most of the spectrum, you know, like if you take audio frequencies, you can basically from 100 to 20 kilohertz, right? I mean, depending on your age, you can hear. I mean, I can not hear most of it since now I'm getting old. But you know, we have a big spectrum in audio. But when you do SSB, we cut a lot of it to save the bandwidth. Just like old days, you know, on landlines, I think none of you were born then. Back then, even on the phone, the audio was not this clear. Okay, yeah. So because of that, we use these what we call Q codes, you know, to communicate. For example, QTH. These Q codes are not only used by amateur operators but throughout in other services as well, like military and maritime radio. So I think we adopted some of these codes from other services into our use as well. So you know, QTH is home or location. You know, what is your QTH? You know, that's something that you always tell when you initiate a radio contact for the first time. Usually you say what is your QTH, and QSL is acknowledging, you know. So basically most of these Q codes are used as a question and an answer as well. You know, like sometimes if I say, okay, the temperature, okay, so WX here is rainy, QSL, that means did you copy that? And the guy on the other side will say, okay, QSL, that means that he acknowledging. So these Q codes we use you know, like in as well as questions as well as answers. You know, the QRM means interference, man-made interference. QRN is static interference, like lightning and stuff like that. QRP, low power. So there are a lot of Q codes. And then we use numbers like 73 and 88. 73 means best regard. So we usually end our conversations with 73. I mean, you probably noticed this when I talk to Victor or there. So like, you know, we do like CQVs again when we want to, you know, make any contact. We may call it it's like asking anybody out there, and of course again, like if you guys notice that when I say my call sign, instead of saying 4S6 CMU, I say 4 Sierra 6 Charlie Mike uniform. So that is the phonetic alphabet. So I'm sure you must have come across this at any point. You know, even when talking over the phone, we say B for bat and C for cat. But amateurs use the standard NATO phonetic alphabet that is used by the military. You know, Alpha, Bravo, Charlie, A for Alpha, B for Bravo, Charlie, Delta, Echo, Foxtrot, like that. So that, and then we have some other stuff as well. You know, we call any male ham operator is an OM, or an old man, right? So we call them old men. So in my case, it's somewhat accurate, but even if you are young and, you know, even if you get a license when you are 15 or 16 years, you are still an old man. And then all the ladies are young ladies or YLs, right? And XYL means wife. You know, you date this young lady and now she's XYL, that's wife. And then we have Elmers, who are like people like Victor, who are kind of like very senior people who operated for a long time. And then we do like these different events like field days, we do expeditions, we go to a hilltop and operate. So those things are part of the ham culture. Okay, let me advance. So how do you become a ham radio operator? In Sri Lanka, the procedure is first you have to sit the radio amateur exam that is conducted by the radio society, sorry, not the radio society, but TRC, which is the governing body, the spectrum governing body in Sri Lanka. And then, I mean, there are 3 exams for these 3 license classes. You can take 3 of them at once. For the advanced class, you need to be familiar with the Morse code. 5 words per minute, you have to be able to copy and send Morse. So that's why I'm not an expert in Morse code, so that's why I settled for the general class license. And then after you pass the exam, you have to apply for the license, and then there's a MOD clearance. You have to get clearance from the Ministry of Defense. You know, since especially Sri Lanka, you know, we long suffered from the terrorism and all of that, because now radio communication they use, or even the terrorists use radio. So you need to get MOD clearance to like even to import radios and keep them. You need clearance from the Ministry of Defense. Once you get that, then you know you can import or build your own transceiver and antennas, and you can experiment and you know, talk to other people. If you don't want to talk to other people, you can use digital modes that we talk about later. Yeah. And then we talk a bit about who we are. And Prarthana, if you want to jump in and correct me or add anything, please feel free to do anytime. I'll talk a bit about the Radio Society. Actually, we are a very old society. We were established in 1950, even before I was born. You know, so initially it was done by the British. You know, after the World War II ended, you know, they had people who are capable of, you know, operating radios, as well as they had radio gear from the World War era, the stuff the World War. So basically, that's how it started. You can read about it in our website as well. Actually, I extracted this from the website. So we have, I mean, so this call sign prefix, regardless whether you are with Radio Society or not, you get the 4S prefix. We have our club call sign 4 Sierra 7 Romeo Sierra 4S7 RS. That is our club call sign, and we are the IARU representative society for Sri Lanka. So the IARU stands for International Amateur Radio Union. So it's a society of ham clubs all across the world. So we represent Sri Lanka in IARU, and also like we did a lot of disaster relief work as well. I won't talk about it now, but I have a couple of more slides about that. So what do we do? Stuff as a club, what we do? We do this field days and contests and workshops. So basically, these are free to members. So I strongly encourage you to become a member. You don't need a license to become a member. You can become an associate member. Towards the end of the presentation, we'll talk about how to become a member. So basically, for members, we conduct workshops by local experts as well as renowned experts from other countries. Because of ham radio, we have contacts with, you know, a lot of experts, like even professors on these communication and electronics, and we invite them to conduct sessions on behalf of the Radio Society as a service to the community. So these are some photos from an antenna design workshop and a fox hunt that we did some time back. So basically, we get together, we learn about antennas in this and design an antenna, and then there's a fox hidden somewhere, a small transmitter that transmits a beacon from time to time. Yeah, so thanks Pratana for the link. So like it's like an entire day of this, we do this once or twice a year, we do this. And then emergency communication. So this is another key thing that we do. uh, when the tsunami hit Sri Lanka, unfortunately I couldn't find any photographs of it. This is from some recent events I'll talk about later. Like the volunteers from Radio Society went to down south, the most affected areas, when we set up a radio station in down south, and we set it up in one in Temple Tree at the Prime Minister's uh, headquarters, and then we coordinated the rescue effort uh, as a service. So we do, radio societies, we are ready to anytime deploy in any emergency. These are images from the recent Ditwa disaster we had. Basically, we deployed 3 teams uh, with the help of the Sri Lankan Air Force and the Indian Air Force. We deployed 3 teams that even before the cellular communication was built up. We took generators. A lot of our guys are trade. We are enthusiasts in survival as well. Uh, when some zombie apocalypse comes, we are prepared. We have generators, batteries, and solar panels, and all that. Most of our ham operators, they can run without power. So we bought our generators and our uh, survival gear and our communications gear, and we provided for 3 or 4 days. We were there in. I was personally deployed as well. I was in Kotmale, so we provided this communication service together with to coordinate, with the government officers and the forces that were deployed there. So, yeah, and also we do emergency preparedness drills as well. About just 2 or 3 weeks before Ditwa hit, we did a drill with a collaboration from the Disaster Management Center. And this was a regional event called IO Wave 2026, where a simulated tsunami scenario was. This was an international event. India participated, so we basically did the communications readiness drill for that. So Radio Society does a lot of work, and if you become a member, you can be a part of this, and be do a service to your country as well. And also we, the another thing that we do is that we take very seriously is Jota, Jamboree on the air. So basically, what this is an international event. So basically, this is where we go to scout Jamboree camps, and then we set up radios, and we let the scouts talk to the world using radio. So Prarthana, again, I think can tell a lot about this, but she's a girl guide, so I think she joined to the radio club by doing guiding. So this is another thing that we do, and there are lot of other events that we do. I won't bore you with a lot of details, but you can go to our website and find out more information. Right, so basically what sort of privileges we have as ham radio operators in terms of the frequency bands. So we have HF, VHF, UHF, and also microwave. In Sri Lanka, we mostly use HF and VHF, UHF. So why do we have so many bands? I think this is again like we can be proud about this as a ham operator. I also can be proud because our forefathers or our ancestors, they pioneered this communication, shortwave communication and disaster readiness, and a lot of these modulation methods and all of these things were originally refined by hams. Uh, so because of that, I mean, during certain eras, uh, government stopped ham radio, like using during World War times and during big wars. Sometimes, countries decided to kind of like stop this service and prevent people from using radio, and we fought back and we got it back. So basically, um, because of that, I mean, even though for a very small fee, we have access to a lot of bands. And why we need a lot of bands is these different bands behave differently on how they propagate, and during what times they are active. For example, if you take the 40-meter band, which is the 7 megahertz band, so the 7 megahertz band works only in mornings and in afternoon. So this we use the 7 megahertz or 40 meters to have a QSO with Victor. So sometime back, right? So uh, basically, and then during the daytime, you work on 20 meters becomes active on daytime, and 20 meters is a very special band. It's 14 megahertz band. um, you using this band you can do a lot of dx in remote, like talking to other countries. So using 40 meters you can do regional communications. It's very kind of difficult to uh, go beyond, like India you can talk to. I think the farthest that I've reached using 40 meters is in Thailand. In one day I managed to make a contact with the Thailand DX group. So like that, 20 meters is you can using 20 meters you can reach very far, and 10 meters is again a very good band. Using 10 meters, 10 meters is active during daytime, around like 12 1 p.m. to kind of 3 p.m. Time. It is very active and you can reach far with that. I made contacts as far as England and Italy on 10 meters. So then we have VHF and UHF. Which is mostly, like if you guys are learning about telecommunication, these higher frequencies are basically line of sight communication. Uh, so you need to be able to see the other person. I mean, not visually see, but there has to be a direct signal path to communicate. So that is used for local communication, and we also run a couple of repeaters, VHF repeaters from the Radio Society as well as one of our affiliate clubs. Right now we have 3 active repeaters. We have another couple more. Actually, they are down because of these current weather conditions and all that. So and then we have microwave that we use to communicate with these different satellites, like amateur radio satellites like QO100 and things like that. And also we can do like EME stands for Earth, Moon, Earth. So you can use it. For that you need a lot of power. If you want to bounce voice off the moon, you can use a array of Yagi antennas and about 500 watts. You can because to Earth and Moon and back it takes about 2.5 seconds, so you can hear an echo of your own voice if you do it. I've never done that, and also that this is kind of like requires a lot of power as well. So yeah, so we can so we have like around about 20 bands. This 26 is wrong, but we have around 20 bands allocated for ham radio. These things do change as well from time to time when regulations change. The ITU allocates certain new bands as well. Right? Okay. Yeah. So in terms of RF propagation, there are various methods that RF propagates. Just like light. Light is again electromagnetic wave, so it reflects, refracts, and it gets absorbed by certain things. So ground wave, I won't go into details about this. I'll just gloss over this. Ground wave is the wave. This is for low frequencies, and HF, the low end of HF, it goes, because Earth is conductive, it kind of like hugs to the face of the Earth and it doesn't go very far. But for example, when I talk to Victor, he's also, I'm in Piliandala, he's also in Piliandala, so that was probably a ground wave communication that you hear. Sky wave is basically HF signals refract and bounce off the ionosphere. There are different layers, D, E, and F. So basically they bounce over. So basically it's like it is like a ray of light. It goes up, bounces off the ionosphere. So basically, we have this what we call the skip zone as well. Sometimes when I'm communicating, I hear people in India, but I can't hear somebody in Kalaniya, that area. I don't hear them on 40 meters because they are in the skip zone. So my signal goes up and bounces off the ionosphere, and it goes to India. But it's very interesting to study how propagation works. Sometimes I think I mentioned that VHF is line of sight, but during a certain time period, like about a month or so before, like that is like during January, February time, an interesting phenomenon happens, and we can hear Indian ham operators on VHF. They can come to our repeaters via tropospheric ducting. Signal paths, various atmospheric changes makes VHF go very far. Especially and also this solar cycle, that sunspot cycle is there, so when sunspots behavior changes, especially this HF propagation changes as well. These other special modes are like sporadic key and tropospheric ducting, and meteor scatter is basically when meteors enter Earth for a brief period, you can bounce RF off meteors and then make long distance contacts. So these are a bit about RF propagation, right? And which takes us to the modes of communication, right? So now you just heard a voice communication, right? So, but earlier we didn't have voice communication. We had Morse code-based communication. So basically that's called CWS, or continuous wave. So that is, your carrier is not modulated, but you switch the carrier on or off. That's why this is called continuous wave, right? So you use a Morse key, something like this, right? And then you tap on it. You have dits and das, what we call short presses and long presses. So basically a long press is supposed to be 3 times the duration of a short press. So like that, you tap it and you can send messages, right? So Morse is still used to this day. If you can let me see if I can show you a Morse transmission. If somebody is transmitting Morse right now, let me turn the volume of my radio and change the mode to Morse. Well, unfortunately, nobody is transmitting now. So, but you can go to the YouTube and find out about how listen to samples about people communicating over HF on CW, and later I'll tell you how you can listen to them. I mean, to obviously to transmit you need to get a license, but to listen you can get a SDR, and I'll talk a bit about that as well. So you have the and with CW the advantage is you don't need a lot of power to go far, because with CW you only transmit the carrier, and then there's not a lot of information, and for that we don't need a lot of bandwidth, as well as you need low power, and you can go far with it. We call this QRP, low power. So it's kind of like a thing that you can brag, saying you did CW contact over this many kilometers with just using milliwatts of HF. That's kind of a thing that ham operators are proud of doing. You design your own antenna, you design the transceiver, and then you make a contact using very low power over a long period. You have to, it takes patience, and as well as a good, very kind of like your propagation conditions has to be very good as well for you to go far. A given minute you might be able to reach America, and then the next minute the propagation changes and you can't even reach India. So that's how that's how varying propagation is. And then you have single sideband. So SSB we use single sideband is used because you don't transmit the carrier, and the upper one sideband we omit. Because of that we can save a lot of power. Like amplitude modulation, we transmit the carrier as well as both sidebands. Since you guys are learning electronics, I think most of you must be familiar with this. AM, it's very easy to receive. That's why we use, and the audio quality is better. That's why we use AM in broadcasting. These days in Sri Lanka we don't have any AM stations, but throughout the world there are still AM stations operating. For AM you need a lot of power, but for SSB you don't need a lot of power. But the demodulator becomes complicated because of that, because the carrier is not present. So we use SSB mainly on high frequency HF. We use SSB, not that we can't use SSB on other like VHF and UHF, but we typically don't use that. So SSB we use both upper USB and LSB, upper sideband and lower sideband. So basically what happens is, like, if it's low frequencies on the lower side of the band, like 40 meters, we use lower sideband. On frequencies above like 20 meters, we use USB. That is by convention, nothing else. It's the ham radio convention to operate like that. And then frequency modulation is again like a voice mode. You can communicate using frequency modulation. We will do a demo of a FM communication on later on a different radio. You can notice the difference in audio quality. So basically we use them in handheld radios and all that. AM, we typically don't use it. It's more of like an enthusiast mode. People like, will try it, from time to time. Okay, shall we try AM? But we don't typically use AM in hand communication. AM is used in airband. Aircrafts use AM heavily. They don't use FM, they use AM. And then we have digital voice modes as well, like things like DS Star and DMR is digital mobile radio. So these different there are proprietary stuff as well. Some transceiver manufacturers have their own proprietary digital standards. Then what that means is they are not interoperable with other transceivers, but things like DMR are kind of like open. So it's open, the protocol is open, so anybody can make a DMR radio. And then we have digital data modes. These are somewhat recent. So basically FT8, JT65 and PSK31 and RETI and APRS. So basically using these modes you make contacts using very low power. even milliwatts over long distances. Like usually to do audio communication, your signal has to be way above the noise floor. But with these modes, even if your signal is below noise floor, sometimes with FT8, even if it is 28 dB, minus 28 dB down, you can make a contact. So that's the advantage of these digital modes. So I think you guys can probably read up on the internet about there are good descriptions and YouTube videos about these modes. Using these modes, you can make contacts like FT8. What you do is you just make a contact, and exchange the signal reports, and that's it. But with modes like RTTY and PSK31, you can do like chat keyboard, like WhatsApp messaging. You can do keyboard to keyboard chat as well. And APRS is automated packet reporting system. This is used mainly for telemetry. Ham radio operators, they can advertise to other operators that they are operating, and then by transmitting these data packets, it's a mesh network. So basically you have mesh repeaters. So in Sri Lanka also we have some APRS nodes, but not as popular as other countries, but we have APRS nodes. And then you can put an APRS tracker on your vehicle and let other people, other ham operators know when you are traveling. And then some radios have APRS built in, so you can advertise, okay, now you are listening on this frequency, so any ham radio operators out there near you can contact you. So that's about APRS. So it's like mesh star stick as well, but reserved for ham operators. And you have image modes like slow scan TV, SSTV. I think ISS has a SSTV downlink, and then so these different image modes that you can use to exchange pictures. Hopefully we can do some demos. I think we have a physical session as well. I think we are planning to do some demonstrations with SSTV when we do that. Okay, let me move on. So what are these gear that we use? We use these transceivers. The transceiver is a transmitter and a receiver both, in one enclosure. So earlier we had differently, like earlier very old vintage ham gear, you have a separate transmitter and you have a separate receiver. But now it comes bundled in one. So you have like HF transceivers. Now there's a photo in this slide, on the side of it. This is Yaesu FT710, which I use. So this kind of like, this is what the grid that I use to demo this HF communication. And then we have this type of handhelds. Like this is a very cheap handheld now with, you can buy for, I don't know, like maybe 5,000, 6,000 rupees, and then, something like this. This is a handheld, just the one that I have in the photo, and this is another one. So you can use these to, if you become a ham man, you get a license, you can start with this. Very cheap. You can, these things support, this is 2 meter and 70 centimeters, so both VHF and UHF ham bands we can communicate using these. And also this base station HF are these that I showed you earlier. And then software, now we have what you call software defined radio. So basically what SDR is essentially is, now earlier we have to build hardware to do the when we are transmitting the modulation and the demodulation and everything, filtering, we had to build hardware to do that. What software defined radio essentially does is it takes part of that responsibility onto software. For example, we using digital signal processing, you can do filtering, right? And demodulation also. For what we call this uses what we call quadrature modulation or IQ modulation. You guys can learn about it. So basically, by using two quadrature signals 90 degrees apart, by varying those signals amplitude, you can change phase, amplitude, as well as frequency. So you can do it as a mathematical operation inside of the computer. So some of these new transceivers, they use software defined SDRs. So they are part done in software. So, and also you get this, I told you earlier that I'll show you how you can listen to these signals. So you can buy something like this, right? So, okay. So this is an AirSpy HF Discovery. So this is a SDR receiver. So this you can buy. So you don't need a license to basically listen to radio. So you can buy one of these. Actually, there are even cheaper ones, RTL SDR dongles, and then you can using software, you also can listen to these signals. Like, I mean, you are more than welcome to listen to ham radio conversations that we carry out. Basically because one thing is, legally we are not allowed to encrypt our communication, so it's open, right? So you can listen to our conversations and our daily nets that we have if you buy one of these, right? And not only that, you can do listen to weather satellites. You can download images from NOAA satellites as well, and you can listen to the ISS and do a lot of things with a proper antenna and a SDR dongle. Can do that. So yeah, so basically yeah, I mean, the QRP rigs are small portable rigs that you carry with you. So transceiver is key piece of equipment that we use, and then it's the antenna, right? So basically, again, like we won't talk a lot of antennas here, especially since you guys probably are studying those in the university. So we typically use dipoles a lot. When it comes to HF, we use wire dipoles because like in HF the wavelength is very long. So like my 40-meter antenna on my rooftop is made out of simple earth wires. One side is 20 meters long and hanging from a mango tree. So that's what I used to communicate just before. And then you have like vertical antennas. We use like vertical polarization typically in VHF. So you can even buy commercial antennas. I use a commercial antenna as my VHF main base antenna. And then you can do Yagis. Yagis are used, we use Yagis to communicate with, because Yagis are very directional and high gain. We use them to communicate on QRP, like very low power, and also we use those in our fox hunts to do directional finding. And there are loop antennas as well. So these magnetic loops, like if you are studying about antennas, most of these dipoles and these vertical antennas, they primarily respond to the electric field of the electromagnetic wave, and these magnetic loop antennas are basically antennas that respond more to the magnetic field. Both the magnetic and electric field has an effect on the antenna, but magnetic loops respond to more to the magnetic field. And like if you use radios, MW, medium wave and short wave radios, has this coil in a ferrite core. If you have seen that, those are like looped antennas. And then mobile and HT whips, we use these kind of like small antennas on these handhelds. And then basically having a good antenna helps you communicate well. I mean, I can't stress this more. I mean, even if one party has a very good antenna, it helps both parties. Even the other party is giving out a very low signal. The guy with the big directional antenna can receive that, as well as his output he can direct towards the transmitting party. Even if one side has a good antenna, it really helps. Okay, so this brings us to repeaters, right? So basically, repeaters are what we use to extend the range of these handheld antennas and even these mobile car radios and these UHF and VHF base stations. To extend the range, we use repeaters, right? So basically, I'll show you a conversation on the repeater. So I think I have some people stand by on the repeaters. So basically, let me just go through these talking points, and then we'll do a demo on VHF. So a repeater is basically it receives my signal and it transmits it out. So usually it's done in a duplex manner where it listens on one frequency but transmits on another frequency. So basically there's a small difference. So for VHF we typically use 600 kilohertz. That's what we call it the repeater shift. So basically what happens is, when I press the button to talk on this, the radio automatically shifts to the receiver's input frequency, and when I let go of the PTT, it jumps back to the repeater output frequency. So that way, although we use two frequencies, I can continue listening to that. So basically, now we have some repeaters. We have one repeater in Pidrutalagala, and we have one repeater in Yatiyantota. So both VHF repeaters, and they are linked together. So it covers most of Sri Lanka, so that ham operators, even where they are mobile, they can operate their radios. And then sometimes some of these repeaters we can use tone to activate the repeater. So we can, these are not really security locks, but to activate the repeater, sometimes you can transmit a tone or a set of tones to activate the repeater. And then these repeaters are linked as well. There are certain applications and protocols that we can use, like echo link. What we can do is, you can link this repeater to the internet. So basically now, even when you are you don't have a radio, let's say for some reason it's heavily lightning and you can't use antennas outside, you can use an app on your computer or your mobile phone to access the repeater. So what happens is, there's a small device that we use that listens on the internet and also transmits on the repeater's input frequency. So we call it an echo link node. So we operate an echo link node that links both our Yatiyantota and Pidrutalagal repeaters to the internet. So basically, other people's, like when you are abroad, you can check into the net. So these echo link connected repeaters, there's a whole bunch of repeaters worldwide that you can access via echo link. So you can join other people's nets and conversations using echo link. So basically, but you need to have a license. Even though it's a phone app, you can't transmit, because end of the day, what you are talking, what you are saying on the phone goes out from the echo link node and it's transmitted on VHF or UHF. Because of that, you still need the ham license to run echo link, right? So you can do that as well. And then when using repeaters, basically you are supposed to, the thing is, ham radio is always only one guy can transmit. It's not like talking on the phone where you listen and you talk on the same time. Full duplex communication is not available on ham radio. So it's always one guy is talking and other people are listening. Because of this, these operating procedures and etiquette matters, right? So you have to pause between transmissions, and then always identify your call sign, and also because you are not seeing the person, they can't see your body language. Because of that, you have to be very articulate when you are speaking. And this rag queue is short. What a rag queue is, again, it's ham lingo for long conversations. Usually, ham radio contacts, you just say hi, bye, and hi, and you exchange your details, and then you just kind of like stop the conversation. But rag queues are long conversations we have. We have these things called round tables as well. We conduct a round table at 7 a.m. in the morning, so people log in and talk about the weather and their health conditions and stuff like that on this. And also, when it comes to etiquette, there are certain things that you are not supposed to. In some countries, those are restricted by law as well. In some countries, it's mainly governed by self-governed, but we don't typically talk about politics, religion, and other things that you can kind of like be offensive to people, right? Okay, so that's about repeaters. And then let me do a contact on. Now this time I'm going to use I'm using a different mic. see the other one, you know, like now I'm going to let me try the Padukka repeater. Okay, so I'll this hear the difference of voice, the clarity of voice. Okay, let me try calling. 406 Charlie Mike uniform calling and standing by on Padukka. Any stations on frequency? This is 406 Charlie Mike uniform calling and standing by.
406 from 406 Mike India Romeo on Padukka.
486 Mike India Romeo, 486 Charlie Mike uniform returning, 59er signal Ifta, and thank you very much for answering my call. Okay, Ifta, I'm just doing these presentations to a bunch of university students, and I wanted to do a demo on both on HF. I checked into the our weekend net, and then for the FM demo, I'm calling you now. Okay, back to you. 4 Sierra 6 Mike India Romeo, 4 Sierra 6 Charlie Mike uniform.
4 Sierra 6 Charlie Mike uniform, 406 Mike India Romeo. I'm actually portable with my handle outside, and I'm getting a very good 5-9 signals from you. And I heard that you are doing a demo, and it's nice, very good. And here, Dehiwala area, my duty is Dehiwala, and here at the moment there is good find there. 406 Charlie.
486 Mike India Romeo, 486 Charlie Mike uniform. Ifta, your last hour was breaking, probably because you are portable. I think probably if you are portable. Nadila, if you are there, can you join us? I need to show these guys the audio is clear on FM. Ifta, stand by. If Nadila is there, can you come on Padukka Nadila for Sierra 6 November, for Sierra 7 November Alpha Data, 486 Charlie Mike uniform?
Here I'm back on my home with my external antenna, 7 lambda. So how copy over?
Excellent copy, Ifta. Now the signal is much better. So so basically, and that's a good demonstration as well on how a portable stick versus antenna rubber ducky versus 7/8 lambda performs. That's a good demo in itself as well. Okay, back to you, Ifta. Okay, Ifta, back to you for the final. Ifta, 486 Mike India Romeo, 486 Charlie Mike uniform.
406 Charlie Mike uniform, 406 Mike India Romeo. Your signal is about 5.9 plus almost 30 dB. That's what I'm getting from the base antenna from my home location in Dehiwala. So, alright, then I will go QRX and I will hand it over back to you. 486 Charlie Mike uniform, 486 Mike India Romeo, clear.
486 Mike India Romeo, 486 Charlie Mike uniform. Okay, Ifta, thank you very much. So thank you very much for answering my call and that demo. Okay, then I'll also go QRT for now. 4 Sierra 6 Mike India Romeo, 4 Sierra 6 Charlie Mike uniform, 73, and bye clear.
406 Charlie Mike uniform, 406 Mike India Romeo. Thank you very much for the USO, and we'll meet again next time tomorrow, tonight. 73, bye bye, have a nice day, and have a great evening for all the viewers who are listening to us. 73, bye bye, 406 Charlie Mike uniform, 406 Mike India Romeo, going QRT.
Alright, so basically now you guys saw the difference, right? Earlier with HF on single sideband versus now with FM. I mean, we are not using broadcast quality FM, we are using narrowband FM, but still the voice is much clear on FM. Okay, so that's actually that was a demo using the Padukka repeater, and we have Yatiyanthota repeater which is linked to Pidurutalagala as well. So okay, let me continue. So I think now how you make a contact or radio. So let's say, for example, now if you want to make a contact on HF, I mean you can also pre-arrange to talk to somebody, and then, but you can always explore the spectrum and see who's out there, right? So basically how you do is initiate a contact is basically on HF you call CQ. Like what I do is, let's say for example I can say CQ CQ CQ, this is 4 Sierra 6 Charlie Mike uniform, 4S6 EMU 4S6 EMU, calling CQ 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 and standing by. So you take a long transmission, and then if somebody is dialing and exploring the band, they'll hear you. Or if they are using a SDR based transceiver, they can see a peak on the spectrum display, and they'll rotate to that frequency and see like who's calling. And then for example, now this is a guy I talk to like on the radio. Now this VU23 VU is signs are from India. So if this guy is called Arun, so if Arun is there, so he will say VU23 kilo mic, or he might just say 406 Charlie Mike uniform, this is VU23 kilo mic, Victor uniform 23 kilo mic. And then usually like ending the transmission, we say the call sign pair, whom you are talking to and your call sign. You always start with that, and you always try to end with that, because we are legally required to transmit our call sign every 5 minutes if I'm not mistaken, and at the end of each transmission. So basically no regulatory body actually listens to this and enforces it, but it's we are supposed to govern ourselves and stick to these operating practices. And then I might say VU23 kilo mic, this is 4S6 Charlie Mike uniform returning, very good morning, you are 59 here in Colombo with me. Name or handle, we typically say handle, we don't say name, that's a mistake. My handle is Chamindu and my QTH is in Colombo, Sri Lanka. Back to you, VU23 kilo mic, 4S6 Charlie Mike uniform. So then so this 59 is basically we use this system called RST to give a signal report. Readability, strength and tone. Tone is only used in Morse communication. In voice we use RS. Readability 5 is you can copy it loud and clear, right? So the signal strength is from 5 to 9. We have signal strength from 1 to 9. That is the strength of the signal. So in typical transceivers you have what you call an S meter. S meter shows the relative strength of your signal, the receiving signal. So when you say 5 by 9, the meter goes to 9. That's like the perfect signal, and sometimes it goes above that. So we say 5.9 plus 10 dB or 5.9 plus 20 dB. So that is like a very strong signal. And then you say what your QTH is, right? And you say what your handle is. So those are the minimum information required for a contact. And also we are kind of legally required to keep a log of all our radio contacts. So there are now online tools to manage that for you, so it's easier. So we are supposed to keep contacts, we are supposed to keep a station log, and then in case an authorities ask for it, we have to be able to produce that, right? And then so like that. So this is a typical conversation that we have, so I think you saw this in a live demo. So like, since you guys are interested in the space communication and all that, so we do have, if you get the license, there are certain things that you can do with satellites and other stuff as well, like International Space Station. So like these Oscar satellites, like orbiting satellite carrying amateur radio, like I mentioned earlier as well, Oscar 1 was launched. That was just a beacon. Now there are a lot of satellites out there, and you can find out more information by going to AMSAT. AMSAT is kind of an organization that manages this amateur radio satellite work, with other bodies. They help you deliver, your amateur radio clubs and organizations to kind of like deploy these satellites. So we have some FM repeaters in space as well. like this SO50, and I think those repeaters you can use to communicate to with other ham radio operators, and as well as there are like some defunct military satellites, but licensed ham operators don't use it, but radio pirates, in Brazil and all that, these retired military satellites they are using to communicate. You can listen to them if you have an SDR, these radio pirates from Brazil. And then we have linear transponders. What linear transponders do is basically they kind of like they relay a slice of an RS spectrum. So an entire spectrum, they just don't operate on one frequency. What they do is they take one frequency spectrum and they relay it. So using those, you can, like, multiple people can communicate. And of course, like I mentioned earlier, you can communicate with the ISS, but I'm not too sure whether they operate the ISS, like the radio while they are going over Sri Lanka. I'm not too sure about that, but I've seen people in other countries communicating with ISS. I personally have not tried making a contact with ISS. You can use if you go to YouTube, you can see people using a cheap Chinese handheld with a home built antenna and talking to the astronauts on ISS. I think they operate 2 call signs. One of them is NASA 1 November Alpha Sierra Alpha 1. Under that call sign they sometimes operate. And working with these low orbit satellites and like things like space station, there's like a bit of a effect due to the Doppler effect. When they come towards you, the frequency increases, and then they go away from you, when they pass over you, like the frequency decreases. So like typically people with cheap handhelds, they program different frequencies into channels and they then shift channels to compensate for Doppler effects. I think some radios have that built in, right? And then you can use tracking tools to track ISS and there's and satellites as well. You can use tracking tools to find out, and especially I think one thing that I can suggest you guys do is still there are these NOAA satellites are getting decommissioned one by one, but I think there are still 1 or 2 sets operating, if I'm not mistaken, and with a simple RTL SDR dongle you can receive the weather map, right? So weather map from your laptop as well. So yeah, you can try doing that. And then there are these other advanced stuff that you can do. I have not tried any of these, I'm not an expert, but moon bounce you can do. Like you can't, with our ham license privileges, I don't think we can do EME voice because we need like close to a kilowatt of power. But you can do like this, some people has done, these AMSAT people that has even done Earth, Venus, Earth signal bouncing. And you can do deep space reception, like you can listen to these different satellites and these orbiters and stuff, rovers that are left in the moon. So people have done that. And amateur radio astronomy, listening to these solar flares, the solar activity creates massive radio waves, so you can listen to those. And this hydrogen line is something that is used to do mapping as well. It's on 1420 megahertz. Like people send balloons, so like people to experiment and find out about propagations. You can do a helium balloon, maybe send up a beacon, or like APRS tracker that transmits telemetry. You can do those things, right? And I'm sure you guys have heard about CubeSats, where universities can contribute and send your own payloads up into there and send telemetry and do various studies. Okay, so I think that takes me to the conclusion. So yeah, I think we talked at least I talked a lot. So yeah, I think I would like to open the floor for any questions as well. if I can answer them right now, I'll answer you guys, and if there's something that I also don't know, I'll kind of like take the question and get back to you. And in the meantime, let me tell you a bit about how to become a member of the Radio Society. Right, so you can start as an associate member, and we are doing this more as a service. So unlike other associations, we don't charge a huge fee from members. Prarthana, correct me if I'm wrong, I think we only charge about 200 or 500 rupees per year from associate member. uh, so once you become a member, you can uh, participate in our events. So you can, I mean, there's a lot of events. We have a annual plan of events that we do. We do workshops, in universities, and we do community outreach events, like we go to these jamborees and all that, and you can participate as a, I mean, even though you don't have a license, when we are operating on these events, when we are operating our club station, 4S7 Romeo Sierra, or any other uh, you know event station, you can also transmit, and you can practice talking on the radio. And there's a lot of things, and like, since especially you guys are studying telecommunication now, I know, like, even though you are studying, you don't get to build your own radio and operate your own radios, right? So this is a legal way to explore this avenue, like. And then also, like, we conduct classes. Like, I'm sure you guys know about electronics, and that part is kind of like covered. But there's a to get the license, you need to uh, learn operating procedures as well, the legal conditions surrounding how to put up your amateur station, and how to operate without interfering other people, and how to tackle if something happens, interference happens, and how to conduct QSOs, how to maintain your logs. All that things are part of the exam. So basically, we teach those, again, like volunteers uh, from RSSL teach those, and we do workshops, practical workshops, like antenna design and focus on those sort of things. Yeah, so I encourage you guys to become members, and then, like, if you are interested in astronomy, radio astronomy, you can build your satellite dishes and listen to those. And yeah, I mean, there are endless things that you can do, and meet interesting people as well. Okay, then, yeah, let me take any questions. Back to the coordinator. Let me take any questions if you have any.
Thank you so much, Mr. Chamindu, for that fascinating and insightful presentation. I know our audience has learned a great deal. Now it is time for your questions. If you have any questions for Mr. Chamindu, you can scan the QR code on the screen to use Slido, or simply drop your questions in the Zoom chat box. We will answer as many as we can. I think there is one question, Mr. Chamindu. Do you think ham radio is important today in an era dominated by internet and mobile communications?
Yeah, so I think we actively demonstrated that, when like, when all else fails, last during the DITWA, we provided communication. So basically, this now I know, like, even the anybody, I mean, government authorities, I mean, a lot of these people have radios too, right? But the thing is, with, I mean, they are also now back to using phones, right? you know now when these things fail, they've only to find out that their radios are not working and their antennas are metal on the ground, right? So, but these our ham operators, we are always on the ready because we have our daily nets, our gear is ready to be deployed and working all the time. So ham radios pretty much relevant. So I think, I mean, not only in Sri Lanka, in a lot of countries, ham radio operators play a lot of important roles when it comes to disaster, right? I mean, even countries like America, they do have these emergency nets as well. Like they, in when bad weather hits, these ham operators get together and they coordinate with authorities. I mean, they are also like kind of designated part of it. I mean, we have a close relationship with DMC, Disaster Management Center, and we are ready to be deployed anytime. So I think ham radio plays a part as well, like a big part, uh, even today, ham radio is a very relevant hobby and a service to this date. I mean, if you can get a one thing. Another thing is, I forgot to tell you guys, you don't even need to buy your own SDR dongle. There are these things called web SDRs. People and organizations have uh, hosted radios, with hosted SDR dongles, and there's this software using a website you can listen to radios. For example, now let me just drop a link on the chat. So this websdr.org, right? Okay. I'll just drop this to chat, right? You can go to there and listen to various SDRs, right? So you can listen to ham radio operators. You can listen to in some countries it's legal to listen to police communications. In Sri Lanka it is not. So even if you get SDR, don't listen to these police communications, right? So but in other countries we can listen to the air band. For example, there are web SDRs in England near airports. You can listen to air traffic controllers, listen to aircraft coming and going. Yeah, so that's that. So yeah, and I think pretty much it's still relevant in this era. Anything else?
Yes, Mr. Chamindu, I think there is one more question in the chat box. Are there any modules related to communication like LoRa SX11278? If yes, can you say about it?
Okay, so yeah, LoRa boards. I mean, there are LoRa boards we use. I mean, for our APRS, we are using LoRa. So long range communication. So I used to run a node up there. I don't know the chipset or the board that I'm using. I'm using this one called it's Liligo. I don't remember the model or the chipset now, but yes, there are things that you can use. So basically, now there are license-free frequencies as well. Meshtastic operates on that frequency in Sri Lanka also. There are a lot of nodes. You can use a LoRa board and connect to the Meshtastic network. You don't need to be a ham to participate in that. But for APRS also we use LoRa, but to transmit on APRS you need a license. We use 433. What is our? I don't remember the LoRa, the frequency that we use. We use 433 something megahertz on our APRS network. Does that answer your questions? I mean, yes, there are LoRa modules you can buy. Although I'm not an expert about this particular module, I can look it up and maybe suggest something later. But yeah, off the top of my head, that's what I know. Anything else?
I think there's one more question. How difficult is it for a beginner to successfully communicate through an OSPA satellite?
Okay. So yeah, again, that is somewhat difficult. like you need. I have not done that yet, and I know like there are some operators in Sri Lanka who use the Kivo 100 amateur satellite. So basically, that is for those you need like down converters and up converters and a basic VHF UHF base station. So it's not as easy as like talking on a uh, through a repeater or talking on HF. It takes a bit of effort, but can be done. There are people in Sri Lanka who have done that. Um,
I think that is it for the questions, Mr. Chamindu.
okay,
If you
right.
guys have any other questions, feel free to contact us so we'll be able to uh, contact you with Mr. Chamindu and let you know about the details. Uh, those are some fantastic questions. Thank you everyone for participating and a huge thank you to Mr. Chamindu for answering them so thoroughly. Before we move to our closing remarks, we would like to present a special token of appreciation to Mr. Chamitu on behalf of the entire organizing committee. Please accept this virtual trophy as a symbol of our deepest gratitude for your time, knowledge, and support in making this inaugural session such a success.
All right, thank you very much, and thank you very much for the appreciation, and also thank you very much for organizing and making us a part of your journey, and also thank you for the audience. I think you guys were pretty much interested in this. I saw through the reactions and through the questions. Thank you very much, and we would be happy to help you guys in the future as well. I mean, ham radio, I mean, as radio amateurs, that this is part of the community service that we like to do and to help, fellow students and also the fellow citizens of our country. And also, yeah, thank you very much for making us a part of this. Back to you.
Thank you, Mr. Chamidu. We would also like to present a virtual token of appreciation to Ms. Prarthana Liyanage for her continued support in organizing this webinar series.
Thank you, Vihanga, and thank you, Dinesh, for inviting us to collaborate.
You're welcome. Now, as we officially wrap up our first SatVision webinar, I would like to invite our ground station manager, Damiru Dilmit, to deliver the vote of thanks. Damiru, the stage is yours.
Good evening, everyone. As we come to the end of today's session, I would like to take a moment to express our heartfelt gratitude to everyone who contributed to making this event a success. First and foremost, I would like to sincerely thank Mr. Chamindu Munasinghe for conducting such an insightful and engaging session on ham radio. Your knowledge, experience, and passion truly inspired all of us today. I would also like to extend our sincere appreciation to Ms. Prarthana Liyanage, President of the Radio Society of Sri Lanka, for her support toward initiatives such as this. In addition, I would like to extend my deepest gratitude to the organizing committee and our remarkable volunteers whose unwavering passion and dedication behind the scenes made this webinar possible. Most importantly, I want to thank all the participants who joined us today. It is for passionate individuals like yourselves that we organize these initiatives, and your enthusiasm motivates us to continue creating opportunities like this. Thank you, everyone, and have a wonderful evening.
Thank you, Damiru, and thank you once again to our wonderful audience for joining us today. This officially concludes the first session of SatVision online series. Have a great rest of your day, and we look forward to seeing you at our next session.